Hello guys, I'm finally back to making those kind of videos that always get me excited, especially when it comes to seeing the results of my benchmarks. In today's video, I tested 5 simple Windows tweaks, and in some cases, they actually reduced stutters more than I expected. Of course, I'll also show you exactly how you can do them on your own system as well. So with that said, let's dive right in. First of all, the testing hardware I'll be using is none other than the ROG Xbox Ally X, as I believe it's capable enough to show some improvement. And I need to talk about the setup I have set for those comparisons. In Armory Crate, I have operating mode set to manual with all 3 power limits set to max, and I have power mode set to best performance in order to maximize the possible gains. And finally, the fans are set to a linear curve on max speed to make sure high thermals don't become a limiting factor while doing tests. I also have CPU boost enabled and the default 8GB GPU VRAM allocation, with all AMD graphics features disabled like RSR, AFMF, anti-lag, and so on. As for the CPU core configuration, it's set to default, so all 8 cores are enabled. I think it's actually really cool that ASUS now have given us the ability to control enabled core counts. And that actually inspired me to try experimenting with different core setups to compare efficiency and performance per watt. I might do that in a future video, so make sure you stay tuned to the channel if you are curious to see how that scales too. Anyway, I also have the latest BIOS installed as of this date, version 316. And in order to make it fair for Windows, all tests will be done exclusively running Xbox full screen mode, given that it's a recommended mode for Windows handheld devices for maximum optimization. With the latest Windows version 25H2, the latest build installed, and all driver updates applied. So everything is running as best as possible on a fresh Windows install. Alright, with all that out of the way, let's get into the 5 tweaks I'll be applying. First, head to Start, search for Registry Editor, and run it as admin. Then here, before making any changes, make sure to save a backup of your registry, just in case you want to revert to changes. To do so, head to File, then Export. This will save the entire registry values you currently have. And you can import them later if needed. Now we'll do the first change, so if you want to follow along, now is the right time. On computer, head to hk_current_user, software, Microsoft, Windows, CurrentVersion, BackgroundAccessApplications. And in here, right-click and select dword 32-bit value and name it exactly like this: Global User Disabled, with each word having the first letter in uppercase. Now if you already have it, you don't need to create a new one, but usually it's not there by default. Then double click on it and set its value data to 1. What this does is globally disable background apps from running. So instead of apps consistently running in the background and consuming CPU cycles, RAM, and sometimes even disk usage, this forces Windows to stop them entirely unless you open them manually. And this can translate to reduced background CPU usage, reduce random spikes, and help keep more system resources focused on your game. Now, if you don't want to set it globally, you can also set it per app by using this other, less effective method. So to do that, go to Windows Settings, Apps, Installed Apps, and in here, you will find all your installed apps. If you want to restrict one from working in the background, click on its actions and head to Advanced Options. For some of them, you may not see this option, but for those that do have it, you can control it here and limit that app specifically from running in the background if you notice it consuming resources. Like in this case, Windows Feedback Hub. In background app permissions, you can set it from power optimized to never. And that's it. Another better method is going to System, Power and Battery, click on Battery Usage, and you will see all the running processes right now. And it shows how long they have been in use versus in the background. And this gives you an idea of which apps are actually active in background. For those enabled, click on the app you want to limit and select Manage Background Activity. And again, set it from default to never. So those two methods I just showed are localized per app, while the registry one is more global and effective. Alright, now the second tweak we have is again located in the registry. So head back to that editor and follow along. From computer, HK underscore local underscore machine. System, current control set, control, power. And in here, select power, right click and create a new key. And name it exactly Power Throttling. If you already have it, you can skip this step. Now inside it, create a new dword 32-bit value and name it exactly like Power Throttling Off. And set its value to 1. What this does is disable Windows power throttling behavior. Normally, Windows tries to reduce power usage by limiting how aggressively background processes and even some foreground processes can use CPU resources, especially on battery-powered devices. By disabling these, you remove those limits, allowing applications, especially games, to run more consistently at full performance without being artificially slowed down, which can help reduce stutters and improve frame time consistency. Now onto our third tweak. Head to computer, HK underscore local underscore machine, software, Microsoft, Windows NT, CurrentVersion, multimedia, system profile. And here you will find by default a key called System Responsiveness. By default, it's set to 14 hexadecimal or 20 in decimals. Double click on it and change that to 0 decimal. What this does is tell Windows not to reserve CPU resources for background tasks, meaning it prioritizes foreground applications like your game, giving them maximum CPU scheduling priority, which can improve responsiveness and reduce delays caused by background activity. And while we are still in System Profile, as an important tweak, click on System Profile, then Tasks, Games. And here, make sure the GPU priority key has the value 8. If it was anything else, just set it to 8 for best gaming performance. This ensures that GPU-related tasks for games are given the highest possible scheduling priority by the system, helping improve consistency, especially under load. For me, it was already set to 8, so that's why I won't consider it among the changes I made. Alright, with all that done, we can call our 3 tweaks complete. Close the registry editor now, and in the Start menu, hit to Run or press Windows key plus R for fast access. And here, run services.msc. Here we'll find all our currently running services. Look for Windows Search, right-click, and go to its properties. Set the startup type from default automatic to disabled. And also hit stop to stop it instantly. What this does is disable Windows indexing, which constantly scans and indexes your files in the background. While it's useful for fast searching, it can cause continuous disk activity and CPU usage, which can slightly impact performance and introduce background load during gaming. Okay, now we can leave that and then again look for SysMain, which used to be called Superfetch. Again, go to its properties and set the startup type from automatic to disabled and stop the service. What SysMain does is try to predict which apps you will use and preload them into memory. While that sounds good, on modern systems, especially with SSDs and gaming workloads, it can create unnecessary background activity, memory usage, and sometimes even stutters. So disabling it can lead to more consistent performance. And that actually concludes all of our 5 tweaks. Once you are done, make sure to restart the device to fully apply those changes. And by the way, those 5 adjustments took us no longer than 5 minutes. But for your maximum convenience, I made the TECHOSAUR System Optimizer app, which I launched last month. And its purpose is to help you optimize, deploy, and comprehensively clean your PC system in a very simple and automated manner, with more features to come. So if you have it, all you need to do is to head to the optimizer page. Then in the Registry Tweaks tab, you will find over 41 to control. And among them, those 5 I showed in this video. They are called Disable Background Apps, Disable Power Throttling, Disable Superfetch, Disable Windows Search Indexing, Optimize System Responsiveness, and Optimize GPU Priority. Those are exactly the 5 we did manually, plus the already optimized GPU priority, which was set by default. And you can see they are active here, which shows our manual changes are all working properly. You can always enable or disable them using the app freely whenever you want. The Registry Tweaks section still packs a lot of cool stuff that I try to handpick for future videos to test in comparisons. For example, I'm curious about the Enable Native NVMe Driver 1, which is a very fresh addition introduced in Windows 25H2 and should improve SSD performance in some cases. So I'll be testing it on the ROG Xbox Ally X next, as well as other cool stuff. So stay tuned. And by the way, if you are interested, you can learn more about TECHOSAUR System Optimizer in this dedicated video suggested here. Now you are probably excited already to see the benchmarks, so I'll get to that right away. So I benchmarked 9 titles, and here we have the before versus after tweaks. All benchmarks running at 900p, which is the norm for most users, and I have the low preset set for all of them to maximize gains and reduce hardware bottlenecks as much as possible. Here our first title is Cyberpunk 2077, and right off the bat, we can notice the higher CPU usage after the tweaks, which is a result of the system allowing more aggressive CPU scheduling and fewer background limitations, meaning the game is getting more direct access to resources. Now we all know Cyberpunk is among the most hardware demanding games, so results might not differ much. But still, here you can see the FPS difference. We got 74.9 average versus 72.9 before. So a small average gain, as well as a slightly improved low FPS. But if we go back to the CPU usage improvement we talked about, here you can see the full graph throughout the test comparing both setups. And we can clearly see the tendency of higher CPU usage on the after run versus before, which had lower usage much more frequently, meaning the CPU was being held back more often. Next game is Horizon Zero Dawn, and here we again notice slightly better FPS values even if small, but the focus isn't solely on FPS. The reason I wanted to capture more metrics this time is because I wanted to look at it on a more microscopic level, and here that actually paid off. If we look at the frame time during this test, we see that after the tweaks, we have a lower frame time overall. If you look at the graph, you can see the lower section is more filled in the after run, while before we had more spikes towards the higher side. And this shows again in the drawn line comparison, where the after line stays slightly lower, meaning lower and more consistent frame time delivery. Next game we have is Monster Hunter Wilds, which is a poorly optimized game as far as I'm aware and runs quite badly even on good hardware. So I still wanted to give it a try. by using its own dedicated benchmark tool. On average FPS and loss, we got almost the same result, but on frame time, we got much better consistency. As you can see, before we had more frames above 8 ms and fewer below 2 ms, while after the tweaks, we shifted more into lower frame time territory, meaning smoother frames. Also, CPU usage was quite a bit higher on the after run, which may help reduce spikes and improve frame time consistency. You can see the CPU usage difference could be around 10% at certain times throughout the test. This shows in clocks. Before we had some very low dips that would definitely cause stutters, while after we have a higher and more stable curve. Again in CPU package power, where before we had more inconsistency and dips. And those dips usually translate into microstutters that we all hate. While after, we have more consistent behavior with fewer drops. Our next game is Forza Horizon 5. And in this one, I saw a significant difference. You can see we got 131 average FPS on after versus 124 on before, which is actually interesting. Also looking at this graph, we see the after run having generally lower frame time. In this comparison curve, we see around 0.5 ms improvement in general frame time, which is a welcome gain. Also, in case you noticed in this game, you can see on the before run, I got a huge stutter caused by a massive dip in CPU clock. You can see how big it was. It literally caused a visible stutter, not a micro one. Sure, those things can happen randomly, but still after the 2 weeks we applied, we didn't see anything as severe. Now next game we have is Age of Mythology Retold, which is a very CPU-bound title, and that's why I wanted to include it. Now results here aren't much different, to be honest, like a 0.1% improvement is barely noticeable, same for frame time. So here it likely comes down to game engine limitations mixed with hardware and not system overhead. Next game we have is Red Dead Redemption 2. While FPS difference is again minimal, we still see a slightly higher trend across the board with the after setup. Also in this title, we have higher CPU core clocks with fewer ups and downs. Before, we had more inconsistencies and fluctuations, while after is more stable. Next game is Shadow of the Tomb Raider, and in this one, I saw a great difference. We got plus 3 average FPS and improved 1% and 0.1% loss by up to around 7 FPS. In the frame time, we see improvement with more frames under 2 ms and fewer above 8 ms. The graph also shows this clearly, where the lower section is more filled in the after run and higher spikes are more present in the before run. Looking at CPU clocks again, we see a big dip in the before run that will definitely cause a huge stutter, while after is much more consistent and clear from any CPU clock dips. Next we have is Final Fantasy 15 benchmark tool, and here I also saw a good difference. Not much in FPS, but definitely in frame time consistency again. We see more frames under 2 ms and fewer high spikes. The graph shows a slight improvement around maybe 0.2 ms difference. Small, but still noticeable. But what's really interesting here are the CPU dips. On the before run, we had multiple ones, around 6 or 7 noticeable drops, which will translate into stutters. While after, we still have some variations, but nothing close to those heavy drops. It was totally worth trying this one. Now the final game we have is Counter-Strike 2. And here we got an improvement of around 3 FPS average, as well as better 1% and 0.1% loss. I also noticed sudden higher CPU usage on the before setup at times, probably due to some background task consuming resources during the test, as it was significantly higher at certain moments but then comes down. It wasn't consistent at all. And again, we saw a huge dip on the before setup, meaning a stutter, where CPU clock dropped heavily, while after results were more consistent overall. So in summary guys, here you can have a look at the 1% low FPS impact across all those titles. Counter-Strike 2 is our top gaining plus 8%, Shadow of the Tomb Raider plus 4.7%, Cyberpunk 2077 plus 2.9%, Final Fantasy 15 plus 2.2%, Red Dead Redemption 2 plus 1.9%, Forza Horizon 5 plus 1.3%, Horizon Zero Dawn plus 0.6%, Age of Mythology Retold plus 0.3%, and finally Monster Hunter Wilds a minus 0.3%. So in conclusion, these tweaks won't magically transform performance, but they absolutely help with consistency, especially when it comes to frame time behavior, stutters, and low FPS, and that's what actually improves gameplay. You get fewer stutters, better frame time stability, and more reliable low FPS behavior, which in real-world gaming often matters more than just raw average FPS numbers. Now before we wrap up, I wanted to share more about what TECHOSAUR System Optimizer app has to offer. Other than Registry tweaks, it has Windows Group Policy Control, network optimizations, control over Windows visual effects, as well as a complete deploter system across services, startup programs, background processes, scheduled tasks, and Windows features. There is also a dedicated system cleaning mechanism allowing manual cleaning per process or a full deep system cleaning in one click. And as you can see, even on the ROG Xbox Ally X, it managed to safely clean 20.95 GB of Windows junk across 28 cleaning areas. So yeah, that's pretty cool. Anyway guys, if you are interested in learning more about TECHOSAUR System Optimizer app, feel free to write your questions down below or connect with me on the TECHOSAUR Discord server and have a look at its dedicated video to learn more. Alright, so that was it for this video guys. If you tried those tweaks, feel free to write your findings in the comments, and if this video was useful for you, please give it your like and subscribe to the channel, as I try my best to experiment with more tweaks and optimizations and share them with you in future videos. Thank you for watching, and I'll see you in the next one.